Okay guys, today we're going to talk about the end behavior of the functions we talked about yesterday. So take out your notes for 5.2. And again, objective students will describe the end behavior of any given function. Okay, so if we could recall the shapes of yesterday, if you look on the left side of the whiteboard, I have linear, remember that was a straight line, a cubic, a quintic, whoops, sorry, that's not quintic, and a quadratic is a parabola, and a quartic. So I want you to take a couple minutes and try to predict with your partner what would your graphs look like if the leading coefficient was negative. Remember that with a parabola, if I have y equals positive x squared, that would be a happy face. If the leading coefficient was negative, that would be a sad face. So take a couple minutes, or I'll give you about a minute, to try to predict how these graphs would look like. And then we're going to get into the end behavior. So go ahead, take about a minute. Okay, that was less than a minute, but you can see that if it flips. So for a linear equation, it would go downhill. A cubic would flip. A quintic would also flip. A quartic would be like an M. Okay? So we're going to describe the ends behavior. What happens at the ends of the graph? What happens at the ends of the graph? Notice that all the ones on the left, the linear, cubic, quintic, they all have the same end behavior. What do you guys know about these functions? What about their degrees? Their degree is odd. They have odd degrees, x to the first, x to the third, x to the fifth. So all odd degree functions, they have the same behavior at the end. What about a quadratic and a quartic? Well, it's an even degree. So all the even degrees, x to the second, x to the fourth, 6, 8, 10, 12, so on and so forth. They have the same behavior at the ends of the graph. So today we're going to focus on how they behave. Okay, let's talk about the end behavior. The leading coefficient determines the orientation of the graph. Remember that the leading coefficient is the number in front of your highest degree. So we're just going to look at the odd degrees. That would be a cubic, a quintic, x to the seventh, so on and so forth. Linear also. When a is greater than 0, that means positive. Your graph would look like this. If a is less than 0, that's negative, then it would flip. And it would look something like this. This is a quintic. Let's talk about the end behavior. So on the left function here, the graph falls to the left and rises on the right. Well, how would we write that in function notation, in mathematical notation? F of x will represent the graph. F of x goes down. What's down? Negative infinity. So on the left side, f of x goes to negative infinity as x goes to negative infinity. Because you're talking about the left side anyway, that refers to your x values. On the right side, so again, since you're talking about the right side, then your x is going towards the right, positive infinity. What's your graph doing? It's going up. So f of x approaches positive infinity. Okay, let's take a look at the right side, the right graph. On the left, the end behavior, f of x is going up. So f of x approaches positive infinity as x approaches negative infinity, because you're talking about the left. On the right side, f of x is going down, negative infinity, as x approaches positive infinity. Okay, let's take a look at degrees that are even degrees. When a is positive, you all know that it's happy face. If a is negative, it's upside down. So what's the end behavior here? The graph f of x is going up. So f of x is going to positive infinity as x approaches negative infinity. And again, since you're talking about the left, then x will be going to negative infinity. On the right side, f of x goes to positive infinity as x goes to positive infinity. Okay, now let's look at when a is negative. On the left, the end behavior on the left, your function is going down, negative infinity, as x goes left. On the right side, your function is going down as x approaches positive infinity, because again, you're talking about the right side. And remember, these end behaviors will be true for all even degrees, depending whether it has a positive leading coefficient or a negative leading coefficient. So now let's practice some. Take a look at this one here. What is the leading coefficient? Make it smaller. Negative. What's the degree of the function? 4. So this is a quartic. The best thing to do here is if you sketch the graph would look like an M. And let's go ahead and find the left hand and right side behavior. So on the left side, what's going on? Your function is going down as x is going to the left, because you're talking about the left. What about the right side? Your function is going where? Down. And since you're talking about the right, your x is going to the right. It's going to the positive infinity. Okay, try this one on your own. All right, what is the degree of the function? 5. It's an odd number. What's the coefficient? Also 5. It's positive. So the graph would start from the bottom left, and remember it has 5 directions, so it goes up 1, down 2, up 3, down 4, up 5. End behavior on the left-hand side. F of x approaches negative infinity as x approaches negative infinity. On the right, f of x approaches positive infinity as x approaches positive infinity. Okay, what about this one? So, same idea except for it's negative. It's flipped. Like that. F of x approaches positive infinity as x approaches negative infinity. So the graph is going up as your x is going to the left. What about the right side? F of x is going down, that's negative infinity, as x approaches positive infinity. It's going to the right. All right. Why don't you guys take the rest of the period to work on your assignment, practice end behavior, so that when I come back tomorrow, we can go on forward and start solving these and we're able to sketch them. All right, have a good day. See you tomorrow.